Have you ever looked up at the night sky, filled with countless stars, and wondered if every single one has its own family of planets, just like our sun? It's a fascinating thought, but the truth is, not all stars are created equal when it comes to hosting planets. So, why do some stars end up flying solo through the cosmos? Let's travel back in time, about 4.6 billion years ago, to the birth of our solar system. It all started with a massive cloud of gas and dust called a nebula. A nearby event, maybe a supernova, sent a shockwave through this cloud, causing it to collapse under its own gravity. As it spun faster and faster, most of the material gathered in the center, getting hotter and denser until boom, nuclear fusion ignited, and our sun was born. But what about the leftover material? The remaining gas and dust flattened into a spinning disk around the newborn sun. This is called a protoplanetary disk, and it's the cosmic nursery for planets. Within this disk, tiny particles of dust started sticking together like cosmic dust bunnies. Over millions of years, these clumps grew larger, from pebbles to boulders to planetesimals, and eventually into the planets we know and love today: Mercury, Venus, Earth, and all the rest. This story of planetary formation is pretty standard, but it doesn't happen everywhere. For a star to form planets, it needs that crucial ingredient, a substantial protoplanetary disk. And here, is the first reason some stars are planetless. They simply did UTN have enough raw material to begin with. If the initial cloud of gas and dust was too small or too sparse, there just wasn't enough stuff left over after the star formed to build any planets. The star would form, but the surrounding disk would be too thin and would dissipate before any significant planetary construction could get underway. It's like trying to bake a giant cake with only a cup of flour. Another major factor is the star's neighborhood. Star formation doesn't usually happen in isolation. Stars are often born in bustling, crowded clusters. Imagine a stellar nursery packed with bright, hot, massive stars. These giants are incredibly powerful. They emit intense ultraviolet radiation and strong stellar winds that can literally blow away the protoplanetary disks of their smaller neighbors. It's a process called photoevaporation. A young, small star trying to form planets nearby could have its disk stripped away before any planets have a chance to form. It's like trying to build a sandcastle while a giant fan is blowing right at you. The sand just gets blasted away. The star's own characteristics also play a huge role. Take binary star systems. Where two stars orbit each other, these are incredibly common. In fact, more than half the stars you see might be part of a binary or multiple star system. Forming stable planets in these systems is tricky. The gravitational pull from two stars can create a chaotic environment. A potential planet's orbit could be easily disrupted, either getting flung out into interstellar space or pulled into one of the stars. While we have found planets in some binary systems, they need to be in very specific, stable orbits, either very close to one star or very, very far away from both. For many binary systems, the gravitational dynamics are just too messy for stable planets to ever form. Then there's the violent nature of the universe itself. Sometimes, a star and its newly forming planets can have a close encounter with another passing star. This gravitational flyby can wreak havoc on the delicate developing system, scattering the young planets and disrupting the disk. It's cosmic bad luck, a case of being in the wrong place at the wrong time. And finally, let's consider the type of star. The most massive stars, those giant blue stars many times bigger than our sun, live fast and die young. They burn through their fuel in just a few million years before exploding in a spectacular supernova. This might not be enough time for a full planetary system to form and settle down. Planet formation is a slow, patient process that can take tens to hundreds of millions of years. By the time planets could be getting their act together, their parent star might already be gone. So, while it's tempting to imagine every star with its own set of worlds, the universe is a complex and sometimes harsh place. From a lack of raw materials and stellar bullies, to chaotic gravitational dances and stars that live too fast, there are plenty of reasons a star might end up without any planetary companions. But this makes the planets we do find, and especially our own precious Earth, all the more special. It reminds us that our solar system is a result of being in the right place at the right time with just the right ingredients. Thanks for watching. If you enjoyed this journey into the cosmos, don't forget to like this video and subscribe for more space explorations. See you next time.